themselves. Ladies and gentlemen, give them a hand as we talk about elevating.
Thank you all for coming out here today. I think this will be an engaging discussion on Rock Nashville. Hopefully you all are able to take something away and learn. First off though, I want to poll the audience here. How many engineers we have in the house? Why don't you raise your hands? Great. What about architects? A couple architects, awesome. Suppliers? Perfect, keep it going. Subcontractors, we're gonna have some subcontractors out there. Here we go, hands going up. About general contractors, a few of those also. Any owners, developers? All right, anyone we missed? Well, great. So you all have a little bit different background. Obviously, you've worked in this market before. I think we'll have something to discuss that each and every one of you can take away as we talk about our collaboration and how our team came together to build this Rock Nashville project. The title of our seminar is Finding Rhythm to Reach New Heights with Stacked Panels. I think this is a perfect way to weave together tilt-up concrete with Nashville's growing music scene. So first, quick introductions. My name is Ken Burling. I am with Maris, who's the developer and general contractor, design builder for the Rock Nashville project.
On concrete construction here in Nashville, Tennessee.
Ben Douglas, I was with American Contractor Supply in Atlanta. We're now part of the Whitecap Group.
Bob Lastage, structural engineer, IC Design Services. We're out of the Indianapolis area.
Great, so as we go through here, I kind of want to highlight our topics we want to cover. Start with collaboration, then we're going to go into design of this project, ultimately construction, then we're going to take a step back and talk about the challenges, maybe lessons learned that we all went through going through this project. So first off, I know some of you all were able to visit the site yesterday. Thank you for those that made it out. But if you didn't, I'm going to recap here. So what is Rock Nashville? Well, it's a three-tilt building industrial complex. Sits just about 15 minutes north of the city. Totaling about 515,000 square feet. And we're going to really focus in on, here, I'm going to use my fancy laser pointer. These two towers in the front here. Those are where we stack the panels, where the primary topic is going to be today. So, Rock Nashville, what do they do and how do they support the music industry? So this is a campus that's going to have over 30 tenants on when it's all said and done. It's anchored by a few tenants I'll name here. Clair Global is a world-class live production and audio systems powerhouse. They provide global touring rentals, cutting-edge AV technology, and proprietary speaker technology. Tate Towers, they're in the front building one of this complex. They're a world-class live event and design engineering firm that delivers visionary, high-credit creations from touring stages and branding experiences. Alcorn Custom Case is one of the smaller tenants in the back of Building 2. They are a Nashville local boutique craftsman that makes custom cases and vaults to protect this valuable equipment when touring. And then the large Building 3 with the studio towers is Soundcheck. Soundcheck is a full-service rehearsal and backline storage facility trusted by the top touring artists in the industry. There's 15 different studios in Building 3. They range from about 600 square feet. Those are your smaller bands. I'm sure some of you all were out on Broadway last night, right? Anyone go out there? No. Surprising. Anyways, they'll rent these smaller studios to rehearse, and they'll go all the way up to the large studio towers. Tower 2 is the smaller one, 84 feet tall. Artists will rent that out to rehearse before they perform in arenas. Think of Bridgestone right next door, your basketball and hockey arenas. The larger one, Tower 1, is what they'll use to practice before they go in stadiums. Think of Nissan Stadium, AT&T, any of those in your hometowns. They'll rent these out for a week or so, practice, rehearse, get their act all together before they break down their stages, their gear, hit the road for a tour. So just real quick on the creation of this project. This is not the first project exactly like this. There's a prototype in Lidditz, Pennsylvania, where they have towers like this. That it is a campus. Now, when us as a developer had made a relationship with some people from Rock Nashville, Rock Lidditz, we said, well, hey, we've been wanting to come to Nashville for years. That's where the music is. That's where the people are. We want to grow our business. So we were able to work with them, find a site just north of the city that worked for them, that would fit their products, their projects, their needs. And once we toured their facility, we said, wow, this is pretty complex. So immediately we knew the mayors, we needed to engage a team of professionals, engineers, subcontractors, suppliers, consultants, so we could make this a reality with tilt wall. So from here, we started collaborating. We got Bob with IC Design on pretty early to be the structural engineer to help us solve this problem. We were originally thinking precast. You know, these are not load-bearing tilt walls like you have in your traditional tilt warehouse projects. It's a cladding. So once we start going down the precast route, we immediately realized that, hey, they're a precast engineer, Bob's doing the structural, more coordination, more things to work around, potentially screw up. So we started thinking, well, tilt. Can we tilt? Can we have one engineer in-house designing the building structure along with the panels? Not to mention, we were having issues with precast. Nashville's not a big precast market. There's no local precast manufacturers, so lead times was the thing also. Trying to get the fit into the tight schedule that we had wasn't really working out. And quite honestly, cost. Precast panels are not cheap. You know, tilt panels come with a price tag also, but we started to engage this collaboration and say, can we make tilt work and make it the most cost?
The pre-construction phase of the project, in addition to the three large warehouses, the Tower 1, Tower 2, saw were initially designed as precast. Understood the problems there, cost, availability. Saw the structural steel was already designed. We looked at the idea of tilt wall, single panel, 94, 96 feet tall, top of footer, 24 foot wide. Did not feel comfortable with that. Just the weight of it, the size of the crane we would need, potential for cracking. Really sure at that time whether it was going to be fully raised prior to the structural steel erection or connected to structural steel secondarily. So started looking at it at that phase and kind of came up with the idea of let's look at the option of let the structural steel go first and stack tilt walls and attach to the structural steel. So that's kind of what prompted it. And Bob was brought in at that time, Ben, some different products, and kind of let Bob talk about the design of the idea to concept of it.
Yeah, so we do have a lot of structural steel backing these panels up. As Ken mentioned, or Will mentioned, they are non-load bearing. There's a little asterisk there. We'll get to that in a second. But the overall towers are 80 foot clear in the big boy, and then 65 feet clear in Tower 2. We also have to stay under 100 feet, I believe, for zoning ordinance. So the approach we did is, speaking about Lidditz, out there, that was a pre-engineered metal building with metal panel cladding. And obviously, we didn't go that route here. It was acoustical reasons primarily that drove that. But we have over here this catwalk that circles the entire perimeter of each tower. And so because we had to kind of stay in this 100 with the concrete, I believe actually we're at 104, so maybe we had 105 feet. But we were getting tight. We ended up, rather than having pre-engineered metal building girders that are pretty shallow and then hanging everything below it, we opted to make this I'm going to say custom. It did come from a joist supplier. This is a custom joist girder. And so we made these deep, efficient. We're spanning 123 feet approximately in the big tower. So this is 11 feet deep in the center, and we've got the ability for that catwalk to pass through. These are 24 feet on center, supported by a really big steel column at each end. And then underneath, we have all of these rigging beams, okay? And these are 8 feet on center, so there's an 8x8 grid spanning to these 24-foot on-center trusses. And each one of these big trusses has 50 tons of capacity for superimposed load. So there are rigging rules for the rigging team, but basically, if an artist comes in and wants to hang something anywhere, more or less they can do it. So, pretty neat to be involved with. We have these lifelines. You'll have riggers 100 feet in the air out, hanging what they need to hang for these performances. And then just a cool little note. So each one of these beams at 8 feet on center, there's a cut joint in the floor slab on that same grid. So it's very easy for the riggers to line up, hey, what's on the ground, where does it go up above? This is an overall view of the interior. This is Tower 1. This is the long wall of the building, so we're 216 long on this. This gives you an idea of we had to pay attention to where we put what, okay? So the steel frame went up first, and that's what all the X bracing is for. That was really just there for temporary conditions, and we had to be mindful. We had connections to the columns, I believe, at 10 feet on center, and then we had panel-to-panel connections every 6 feet on center. And this gives you a little bit of a view of where our stacking panels were done. So, for example, we had to make sure these girts here, for the engineers in the room, these are providing some compression bracing to the columns, bringing those loads or that stability back to the X bracing. We had to move those, make sure those are out of the way for Will's team, so when they went to connect everything, they had the room. Same thing with the stair tower here. See the big red clouds. I thought it would be fun to leave those on. We didn't get it all right on the first try. But we had to move these. Basically, this stair run is in the plane of the steel, whereas this one's kind of out in front. Cantilevered a little bit. So we had to move these from where we had them because we had created a conflict we didn't recognize with the stairs. So non-load bearing tilt panels, right? Asterisks. They are self-supporting their own weight, and they're actually the lateral system in the finished condition as well. So they're cladding in that they transfer the out-of-plane wind loads to the steel structure, but they're not hung off of the steel. So we're 8 inches thick, and we're spanning side to side, not top to bottom. So not a very stressed panel, right? 8 inches thick, spanning 24 feet. Not a problem, but we needed the mats, and they're uninsulated as well, standard weight concrete. All that helps with the low frequency sounds that these artists are going to be producing. So, and then the connections. This is where Ben and Will really helped me, because we were already doing the steel frame. We were anticipating a precast cladding. We've done a lot of industrial design, but this was new, this was different, and it was how are we going to fly these panels and then attach them to the steel. And so we have a mix of proprietary inserts and just conventional embeds and welded connectors. So we have some, the panel to steel connections was a proprietary insert. Up at the diaphragm, so these panels, like I said, are the lateral load element for the towers. So we have a different type of connector at the roof diaphragm to get the lateral loads out into the walls. And then just typical panel-to-panel connections were welded. And then finally, where we stacked the panels, we went with elastomeric bearing pads, 3/4 inches thick, nominal spacing to just get the loads down to the foundations, since we're not hanging off the structure. I'm going to turn it over to Will and Ben. They're going to tell you a little bit about those proprietary inserts.
Erected and attached back to the structural steel. Initially, we thought welding would be probably the only feasible way to make that happen, but knew that was going to be really slow with the crane, with the crew on site, making it expensive. Knew that was not going to be good for the schedule either. So reached out to Ben at that point, taught him kind of the challenges, walked him through the deal, and He came up with some products that we were able to use, and then we set up bi-weekly calls at that point to talk about different connection methods and different potential products. I'll let Ben kind of talk about what he presented to us.
Yeah, so when I got the call from Will on this project, it was exciting because typically as a supplier, we're relegated to general notes, specifications, you know, what do the engineers tell us we have to use. Some of our customers can be a little picky about what they like to use, what they don't like to use. We have the challenges of what we have in stock, who are we set up with, what can we not get, what can we get. But this project was totally different in that it was a blank slate. You know, here's the project, here's what we need to do. Now how do we get it accomplished? So all the years of the trade shows and the meeting at the booths and the vendors coming in was kind of nice. We had these Teams calls that were set up, and the first product that came to my mind, and we're not up here to really promote specific names, but can talk to me later about it. So these manufacturers are here today as well, but these embed connectors, typically when we get in a tilt-up situation and there's a non-welding situation, would be a corner connector or a spandrel panel. Somebody wants to just reduce crane time so we can go to a bolt-in application. A lot of the slot channel anchors that we found, I think, were more of a precast application typically, but opened up the catalog, started sending Bob and Will pretty much on the Teams call. Here's 2, 3, 4 different options, and it was just a matter of letting them dictate down what specifications were going to be needed to accomplish it. So the bolting connections, you can see as this is pre-installation, installation, and as it was installed there. So the welded anchor. If anybody did the tour yesterday, if anybody did the tour yesterday, if you walked in on the I-beams to your left and to your right, these channels and these bolts were pretty much chest level. So you did get a chance to see how they look. All right. So the bolts, one of the challenges that we had initially was the space between the steel and the inside face of the panel was going to be a lot tighter than a 12-inch long bolt. So Will's team had to preload the bolts here. That's why these are not just staged photos. We had the pre-installed 12-inch long bolt that was a T-slot bolt that was going to go into this embed channel. And then after it was installed, it got tied off, and there's a lot more discussion about that later. On the roof line, as Bob mentioned, we had a different application that had to be installed. So we had a T-slot anchor that was cut to the size, which created another challenge for these guys down here in the front row, that they had to make sure this channel was in the proper spot and the other channel was in the proper spot, because if those got mixed up, you got a real big problem when your panel's hanging up in the air 80 feet. So a lot of coordination went into it on the front end. There's a little more discussion about how these fit and how they work along the roof line. But all in all, this is a pretty successful application for these products. So the other item on there that was a really big item on this building was the form liner. And anybody who's done form liner knows a lot of times you've got seams and you've got a lot of sack attached, and you've got to have a lot of stuff sometimes in the back end to get that completed. So we dug through a lot of different manufacturers on this, and we did find a product that basically allowed us a little more on the front end to purchase it, but it allowed us almost an elimination of seams altogether. This product was a vinyl lock product that locked together, and one of the nice little benefits we found as we kept going in this process is we could custom cut all the lengths of these sheets of form liner. So since we had 20-some feet on the bottom panel and 20-some feet on the top course, and a little bit more or less on the middle course, we were able to work with our panel shops, basically get a cut list for everything that Will and his guys needed, and stage it effectively. Bring out the form liner in the custom length sheets that they needed, allow us to get installed, and I don't know how much that saved you at the end, but it had to be a ton.
Yeah. And the rub out the horizontal seams, we just didn't think that was gonna be practical.
And the horizontal seams, I mean, with typically your sheets, gonna be a 4 foot by 10 foot single use sheet. Well, now we were able to go up to 40 length, and with these being vertical ribs, that took all of the horizontal seams completely out of the equation. So even in the winter time in Nashville, it's still cold. And I don't want to be up in a 90-foot aerial lift rubbing walls, and I know these guys didn't either. So it was a great benefit. Panels were going up, and I think that even when we were there, as later in the project, panels were still getting stacked, and there was already priming going on, so it really expedited the process hugely. So Will is going to take over a little bit and talk about the mock-up panel and kind of what we learned in the formliner applications and how that equated to then the construction process.
I learned a lot from this with the team. Really how the panel joints were going to work, and the corner conditions presented some different problems. As we wrapped the cube of the tower, how the different corners were going to stage out and how the 1 inch reveal would go around the corner. The other thing we realized was we've got two 24 foot wide panels at the bottom that get capped with a 48 foot panel. The panel joints were 3/4 of an inch wide, and the form liner was 1 inch. So we were so far down a path with design, lifting, and bracing that we really couldn't move the panel joints at that point, and just had to adjust for a 3/4 inch and make it stack and keep everything vertical. So we learned that during the mock-up, and learned we were the other thing we realized was, we did have an as-built essentially of the structural steel that was there and how we were going to bolt to it, but we realized if the slotted connections were too far off, I mean, the fix may be to destroy the panel and make another one. So really just put a greater emphasis on quality control and what our teams were going to be involved with. That's when we got started. Mobilized to the site, put the tower foundation mat footings in for tower 1 there. Structural steel was being erected. We started out by pouring, that's roughly 105,000 square feet of 5-inch thick casting bed. Left ourselves a crane road access between the beds and the structural steel. We built the panels in pairs. There'll be some other drawings here in a second that kind of showed that, but 24 foot wide. Yeah, go ahead, next one. So this is our panel layout, our crane road. So the photo to your left with the orange, that's the crane road around there. You can see that the panels done in stacks. So these are 24 foot wide, 60 foot tall. 2 of those, and then they get stacked with an 18 tall by 48 wide and another 18 tall by 48 wide. That mirrored the structural steel that was on site, and just by building that all in pairs from finished floor up to roof elevation, it kept everything straight, kept everything aligned. We realized the form liner, how that was all going to look, and the panels were also built in reverse of where they went in the world, just to keep the panel construction joints straight as we erect them. The second photo here, this shows, let's go back one there, Ken. Yeah, the second photo shows after we got the towers erected, we demoed a large portion of the casting bed, and then there's a loading dock, low roof, tilt wall panels that sit outside of this. So the subgrade was built up. The beds were all level for the crane road. We had to demo the beds, lower the excavation, cast those panels, and then erect. I guess that was actually the third set in those towers. So. This is an elevation showing the different stacks. Again, the 24s by 60s, and then 18 by 48s twice. In the center, we had one that kind of went up to the top, just a single stack, but this was tower 1 with 3 stack panels going all the way through.
talking about sequencing, a lot went into these towers that we had to work through with everyone on the site or on the project team. But another added challenge that you have on a lot of construction jobs is this is not the only activity. I love this aerial. It gives a good picture of we're doing foundations on building 1. We're still rolling around, starting to prep slabs on the rest of building 3, underground on building 2. You see the excavation work being done for the detention pond. There's not a lot of room here, and to work with Will and his team and everyone involved to pull off the complexity of this tower amongst an active construction site with other trades, it was a pretty impressive feat that we were able to accomplish. I mean, on average, once we started concrete, we had 150 workers on site every day. We still do as we're finishing the building now. Sometimes that'd be upwards of 200, but very busy site that we had to work all these details into and around. Well, you want to talk a little bit about the installation of the form liner?
Yeah, so as Ben mentioned, we knew that horizontal seams were gonna be a big issue. So got the full length sheets. That was a big win, but you can see as we were starting to do their repairs, the form line. And then the next slide shows the upper portion. So the lower of that, those are your 60s on the bottom with the 3/4 joint. So we just pulled that pairing all the way through with the 3/4 inch reveal chamfer in the middle, and then just pulled the form liner vertical on either side of the center line there. You can also see a little bit of deviation in the panel construction joints. Our guys knew to build those in reverse just to keep all those married up, and the form liner stayed really true as we stacked through. So these are the initial erection, Tower 1 and Tower 2. These were the only panels that were temporarily braced on the project. The reason we had to do this between the corridors was, I think, 25 feet, which was too narrow for the crawler crane to get in. And the panels being 140, 150,000 pounds, we couldn't reach them from the sides if Tower 2 had been erected. So erected walls on Tower 1, braced back to the footings of Tower 2, and then vice versa, Tower 2 back to the footings of Tower 1, and then let the structural steel go secondarily to Tower 2.
Good. Here's another picture of panel lifting. If you caught Will mentioned before, we had 105,000 square feet of casting bed. It was 5 inches thick, a little thicker than you typically need. But we had to do transfer picks on all these panels. So once they did get these picked up with an 8-point pick, I think.
Yeah.
Stand it up, brace it, and then bring the crane up to the top picks. So it took a little bit more time, obviously, than your traditional tilt. But again, for this specialty building, specialty application, it was the right solution. We started out, we set about 2 a day, and eventually found some rhythm.
We got 4 or 5 sticks, depending on how it was going. 10, okay, so you guys say we did 10 one day.
That's good.
So yeah, this is a photo of every panel was done the same way. Erected, facelift. Those were actually 16-point picks, the little mini spreaders on a conventional 8, and then braced back down to the casting bed, unhooked, and then rehooked with a vertical top set. And the reason we had to do that, there was only 3 or 4 inches from outside face of steel to inside face of tilt wall until we got to the roof line. And then once you got to the roof line, it was nearly 0, probably a ½ inch or less. So having the rigging caught in behind the panel between the structural steel, it wasn't going to work. So they were all done that way and spun in reverse and bolted into place.
Here's a photo of what Will mentioned earlier, where we had to cut the dock or cut the casting bed out, lower the grade. This is your typical dock elevation. If you're familiar with industrial buildings, your dock always sits 4 feet lower than the finished floor. Well, we needed the space for the vast majority of the towers. As you see, the towers painted black already or erected. Once we had to set the dock wall panels on that make up the true exterior of this building. Again, more coordination. Remove casting slab, cut the grade down, get the crawler crane back in there peg and swing panels from the remaining casting bed over in place to their final resting place. These next photos, I'm just going to kind of talk through real fast. I think, again, they show a lot of what's going on with this project. So this, you see the crane inside the building. Bob mentioned earlier where we were setting these, I don't remember what they are, 15-foot-ish deep joist girders. They would come to the site in two pieces. We erect them, connect them on the ground before flying them up. You see all the casting bed we keep talking about there. The site work's ongoing. Just again, very, very busy site. This shows the tower has progressed a little bit more. You see the roof decking going on. One thing I want to point out here, you see a lot of so in this photo, you see the roof decking going on there. One thing I do want to point out is all the rock around the site. That's a blessing and a detriment to working in Nashville. Y'all heard of Rocky Top, right? You hit rock quick. Makes it more expensive, a little slower on the excavation side, blasting on just about every one of these projects. Benefit is we can harvest that shot rock and spread it on site for both access but also crane stability. So a lot of that rock you see there, some is gravel we import for the slab, but a lot of it is rock on site that we're able to utilize to give the crane its bearing pressure as needed. Again, this photo just shows some of the other buildings in the background, tilt walls, traditional tilt walls being stood on the top there, and then you see panels being formed on building 2 on the other side. All right, now I'd be remiss if I would say we finished this project and had 0 issues and it was the best, most perfect project ever. It wasn't. Like most projects, we run into challenges. So I want a team to talk through a little bit about that so we can learn from this and you guys can not run into the same issue we ran into on your next project. So Will, you want to talk about the bolts here a little bit?
Yeah, so I don't know if you can really see it from the photo, but the bolts were twisting a little on us. They were getting in a bind, and this was happening from the initial erection set, and as we started doing it, they started twisting a little bit more. So we were tripping on that. You know, how much can these move? You know, where's failure? Reached out to Bob at that point with the Maersk guys, and you know, raising our hand, what do we do here? And Bob calmly said, you know, just think of this as tuning a piano. You know, just back your bolts off when they're in tension, find another bolt in the same elevation that's not in tension, that's loose, and tighten it up. And, you know, I said, well, this is like 500 plus yards of concrete per elevation. I think it's a 2 million pound piano, you know, in a boat. but it did work. You know, you could see the ones in tension, back them off. And retighten. You know, some of the bolts were pushing on the inside face of the channel. Some of them were pulling. So that actually worked really well. So.
Thanks, Will. So this is the detail of that connection, and yeah, as an engineer, I wanted all these bolts to just be neutral, right? We don't want any pretension. We don't want anything that's the purpose of these bolts. It's just as the wind blows on the panel, the bolts are taking the load back to the column. And so yeah, we had this tuning problem we had to deal with. And one of the things, Ken, can you go back to the previous slide just for a second? There's no bolt there. Or, I'm sorry, there's no nut there. And then go ahead back, Ken. Well, there's a nut there, and so this is my detail. I drew this. I drew the nut, and I drew the washer. That note wasn't there originally, so we had another little fun incident here. Hey, Will, you sent me that picture with the bent bolts, and yeah, we tuned the piano, but there's a nut missing. Sorry. And, you know, to Will's credit, he went, oh, well, you drew it, you didn't call it out, but I should have caught that. So this is a good example of we really all, from the beginning, collaborated, worked together. This wasn't engineer versus contractor ever. We had a very special project. We knew that. We wanted to make sure we got it done. So taking the bolts back out wasn't an option. We had made these extra long so that there would be no issues with the bolt being short. And then what do? So we put our heads together and found a split washer, or split nut that we could get installed to take care of that. Because we needed that that T-bolt locked into the panel. Because in a lot of things would have to go wrong, but theoretically, if there was a little bit of slop in that connection there, you could see that T-bolt turning and potentially disengaging. We just couldn't have that. So that was one of the solutions we came up with. And then this up here was basically a means and methods, right? This is a sequencing for erection note. So I couldn't put tune piano properly on the contract documents. So what we did is we kind of came up with this, hey, when you're building it, this is going to be finger tight, this is going to be cranked down, then you're going to go through, you're going to kind of try to get all that pre-tension or compression out all these bolts, get everything lined up. Then after you make your panel connections, then you're going to make those adjustments, and then we're done. So yeah, we ended up adding the sequencing instructions. And then we also had a note to follow the threads because we didn't want anything backing off. This is, earthquake loads. I do want to briefly mention this is a size of design category C, which was huge. If it was a D, this would have been a much different project. But our wind loads controlled over our earthquake loads, and just kind of that, cyclical loading of the wind and the earthquake. We didn't want anything spinning off. And so I talked to Will, he said, yeah, what if even someone comes by on the stairs and wants to loosen one of these nuts? I said, well, no, you're gonna follow all the threads. He goes, follow them? What? I said, peen the threads, weld them. Really, those are your only two options. Well, we thought of a third option, could we put thread locker on? So we got a couple submittals, reviewed those, and yeah, that's what we went with. So if anybody's familiar with Loctite from the automotive applications, we went with that. And Will, did you try yesterday? I tried turning a couple of nuts off.
They're stuck well.
Yeah, we couldn't get them loose. So yeah. And this is another one, how it's drawn versus how it's built. So what you see here in the detail is we wanted these channels. Ideally, these channels for construction would have been up higher, but we needed to hold them down about 2.5 inches just for embedment of these anchors. And in the picture, it looks great, right? Oh, there's still plenty of room there, we're fine. What you don't see in this detail, which was in the detail next to it, is this splice plate. So this is a splice plate, this is our cord for our diaphragm. And that splice plate, when you added it on top and you deal with construction tolerance, we couldn't make this connection. So we had topped out, and fortunately, this only occurred on the long walls of the towers, and we had designed the higher demand for this connection, because this is the main lateral connection, getting the load out of the diaphragm and into the shear walls. Fortunately, we didn't run into this problem. This was only a problem because of the gutter. Basically, we had a gutter condition. We had to push everything down. So we were able to say, hey, on these long walls, we were a little conservative in our layout. I think there were 7 of these total between the two towers that couldn't be made. It's pretty good. We just told Will's team, hey, don't worry about those. We're okay. We've got spare capacity. And then this picture here in the circle here, I'm gonna turn it back over to Will. We had a little fit-up issue that we had to come up with a cool selection
One, probably 1.5 inch belly. When different times of the day, sun coming through, it looked really bad. We don't know exactly what happened. We had reused the casting bed several times. I'm not sure if we had a belly in the casting bed. Potentially on the top lift, got our rigging not spaced correctly and may have put the panel in tension there. Not 100% sure, but another one of those items. Talked to Bob about. He said, "Man, I think we can torque it back in with some nuts and bolts. So the next slide, sent a guy up in a boom lift. We put like a washer and plate configuration with a bolt through. Those were probably every 5 or 6 feet on center. Rehooked the crane, taking the weight off of the panel with an impact, and just sucked that panel back flush, and then welded the stitch plates on the inside face while they were being bolted back together, and then T-bolted everything back up and took it back out. I don't think we have anything out there over a 1/4 inch or 1/2 inch out of tolerance, so it worked out well.
Very good. Just to wrap things up here, a couple of photos of the finished product. This picture was taken about a month ago. I love this because it looks like a rendering. Sometimes renderings look like photos, photos look like renderings. They've gotten so real these days. But this shows is a great shot of the towers. All black. That's Rock Nashville's branding. They're mostly black. Rock stars. Here we go. Yes, the Rock theme, that's their brand. They have yellow accents highlighting entrances and other parts of the building here. They've gotten a great response, they being Rock Nashville. This product in Nashville, you know, there's so many artists that are local here, they call this home. They don't want to fly or drive their whole team to Lidditz, Pennsylvania, or wherever it is. So to have this in their backyard has been very well received from the industry. I mean, these towers are mostly rented already for 2026. I'm not allowed to say any names, but people like Morgan Wallen, Chris Stapleton, Lainey Wilson, they're very interested in this and will be, you know, using this as their home starting next year. Here's an aerial taken again just a few weeks ago, topping the asphalt, finishing the site. I like this picture again. We're focusing on the studios. The buildings there, there's your typical 36-foot clear industrial buildings, and to see those towers literally tower over top of that, about 94 feet tall, it's pretty impressive. And the last thing here I want to point out, you can't really see it too good from this picture, but on the next slide, you got these gray panels at this kind of corner entry as all the buildings come together. It's another feature design that we did with the tilt walls. Will's team put these reveals in here, you know, symbolizing music notes. Fun fact is, it actually reads twist and shout. Or Will joked, I think, I'm really not sure if he's serious, he said they did it backwards and it actually says shout and twist, but it still looks good.
Nobody can read that.
Too many buttons here. All right. So just kind of recapping us here. Hopefully you were able to learn something from this as we went through the collaboration. You know, there was no egos on this team. We were all aligned with a common goal. Nobody was in it for themselves. We wanted to be part of this fantastic project and to make it good for everyone. You know, from the design, Bob can design any kind of panels we need out there, but once we got into some of these special connectors, you know, he didn't have the expertise that Ben was able to bring with the different fasteners and connection types. The construction, as we talked through, pointed out in the pictures, just so much coordination, working through issues, not a lot of chance to redo something on this one, you know, it had to go perfect. And then the challenges, again, as I mentioned, all projects have challenges. I always like to say it's how do you react, how do you navigate through them? Because they're not going away, but they ultimately have to be done. So with the team that we had, we were able to get through all of that. And ultimately, we're going to finish this project on time next month, which is good because I mentioned it's already booking up for 2026. With that, I'm going to wrap it up here. I'll turn it back over to Mr. Lester.
All right, give these folks a hand. What an exciting, kind of introducing, interesting presentation. So, kind of questions that we might have for the team. They went through some very good detail of how they got some of these challenges dealt with, but I'd love to hear from the folks in the audience to ask these folks some questions.
You have
crane hanging? Just trying to understand that portion of it.
So he was asking, how do we, if there's no bracing, how do we get the guys in the right spots to safely erect these panels and tie them back to the building? Simply we just put guys in boom lifts on the outside face, guys in boom lifts on the inside face. We made some little jigs from the panel below to slide them down in a slot, take a little pressure off, make sure everything lined up, and then we just bolted them into place. Had radios and signal guys, made sure everything was tied and in tension, slowly let the weight off the crane, and they were good. We did put some thought into, and Bob worked with us too, is it kind of means and methods to a certain extent, the lower wrap, loading the building, loading the foundation, and then those bolts were getting in tension. We learned that, once you got to the roof, it was pretty stable, but until you got to the roof, it was a little squirrely.
I think Mitch is around with a question. Anybody else have a question?
Where's the question at?
There's questions. We got a mic for you. One up front, Mitch.
Hold on.
Everybody wants to hear your question.
This is for the engineer. How did you deal with the thermal effects when you tied over the panels to
200-foot length on the longest face, and we made the decision that we would prefer to have these tied together, and because of the lack of restraint at the long ends of the wall, you're basically dealing with a 100-foot expansion contraction from the center of that, and we were okay with that. We were comfortable with that. So we wanted these panels to all act as one big, long shear wall to get that load down as safely as possible. So we ran the numbers and didn't have any concerns.
To the back.
For the outer plane forces, those would come out of the panels into the steel through those T-bolts that you saw, and then we had steel tubes, 2.5-inch tubes basically everywhere to get the load out of the steel and into the deck. So for the outer plane, it would come in through the joist, right? So the load path was walls to perimeter members through the T-straps. That took it into the joist. The joist got up into the deck, and then coming back out of the deck, that's where we did, to prevent rollover issues, when we got to the end walls, we had tube steel to get the load back out of the deck into the steel, and then from the steel through those T-straps into the panels.
One thing to add on that, that's the engineering side of it.
The 2.5-inch tubes, the deck actually, the deck angle attached directly to the T-straps, which were cast into the panels as well. So the concrete was not needed for structural purposes. We were going to be able to handle the diaphragm forces just with the standard metal roof deck. But yeah, the acoustical report came in and asked for that. That's how we got what we did.
Other questions? That move.
When you were erecting those panels, did you have to utilize shim packs between the stacks? And then also, second part, did you run a common header vertically between the panels, or were they broken apart and cast independently?
Yeah, we ran a vertical header as a construction joint between those panels, yeah. And then, but no shim packs. I mean, they were 3/4 inch elastomeric bearing pads, like a real dense bearing pad that I think we put them like every 5 foot on center as it spanned the 48-foot stack. And then we kind of staggered them the next one up. And then just caulked to hide all that between them. That was just a 3/4 inch bearing pad every 5 foot.
So, one of the things in this piece is talking about seeing the difference. Like, there's a lot of unique pieces that happen in this project that has some really have to have some challenging solutions. So how do you find the difference in here, right? I guess the difference of, you know, there was tilt up not being kind of going from precast to tilt up in this space. And talk about some of those unique challenges that you all had in this piece and how the right team was important in making that happen with some of the uniqueness of it and picking the right engineers and the contractors. And I think people can benefit from how you guys get that.
I guess Ken, you probably be the one to answer that one.
Thank you. It's a great question. I mean, as a builder, we thrive in these situations. We like to tackle new, different projects. And, you know, we've done some very unique builds before. We've not done a sound tower like this. So, first off, it excited us. Second off, we knew that we had to have the right people on board. We had a sound consultant, you know, to help us with some of that design aspect. But we knew we needed to get these guys that are sitting up here on the stage involved. We have a great relationship with Bob and IC Design, worked many projects with them, so got them in early. And then, quite honestly, I think it was J-Town's idea for tilt. You know, we were sitting with a meeting, and he's like, I think we could tilt this. And at first, I'm like, what? Okay, let's talk about it. So, just developing that open-mindedness with the team and our familiarity with each other in these type of projects ultimately helped us accomplish what we needed to.
Yeah, there was definitely some talking the engineer into this on this project. You know, we had some issues initially with trying to coordinate with the precast option and how are we going to, you know, accommodate different things. And yeah, it was I think it was Will first said, yeah, let's talk about moving this out of tilt. And then the Maris team had to come to me and go, well, Bob, what do you think? I went, I don't know. And then that's where Ben came in and was able to tell us, hey, here's what we think you could use. And I went, okay, well now I'm starting to feel better about this. So yeah, different type of project, different, not just, you know, the designers doing everything and then telling the contractors to build it. It was not that at all. This was very design build, pushed forward by the construction team.
This kind of rolls into my next question because I think the through lines here, right, of not only the seeing some of the difference and the value in that, but also what comes with doing interesting things or maybe some things that we have to be talked into is the trust, right? You know, people do business with those who we know, who we like, and who we trust, especially if it's a unique situation. So talk about some of the, you know, the trust that has to go into trusting everybody's expertise on such a unique thing. There's many pieces of this process that had some proprietary things, some unique challenges, how to trust and even the vulnerability we talked about earlier. Because you know there were some things that might have been missed in the diagrams and et cetera that came back and we caught later. Talk about how that worked out.
I remember we were pretty far down the path with, you know, during the pre-con phase, and you know, we said, yeah, we can do stacked tilt walls, and we were in with the Maris guys, and they was with some of our J-Time guys here, and they said, all right, we're gonna give you the job as a tilt wall, and our guys were, you know, great. And I just had this sick feeling, you know, like, oh man, they took it serious. So, kind of had that feeling like my wife told me she was pregnant. You know, it's like, hey, this is gonna be great, but it's a responsibility thing. But you know, we set up bi-weekly calls. We started working through the problem. We kept it all pretty organized. And I know stacked tilt wall had been done before. We had never done it, but the deeper we got into it, the more that we thought about it, the more comfortable that everybody felt. And as Bob said too, I mean, once we did have some problems, I mean, it wasn't anything we couldn't work through. It was a trust factor. We had made it this far. We all felt good and knew there was going to be a good outcome. So
I think some other folks can be beneficial to hear.
Our team, because we know that, look, this is a challenging project, and it's going to get built one way or another. So what do we do to get it there? And that was the collaboration part that really took place really quickly, actually, I think. We all kind of came together, these bi-weekly meetings that, you know, at first it's great, it's another team's call. We're gonna go over schedules, but next thing you know, we're firing off, you know, product data and getting things designed right there on the fly, and it was a lot of fun. You know, and we had enough time ahead too. We started that early on, that we didn't have to, everything was not just under the gun. I need books in a week, I need submittals in a week, and next thing you know, we're gonna start panels in 2 weeks. We had a lot of time to prep and plan, and we were comfortable with each other. You know, we knew each other, so everybody could trust everybody in that regard. Yeah.
One thing too, you got to know what you know and know what you don't know. You know, which I'm not gonna lie, so much of this stuff was way over my head. I've been doing tilt buildings for I don't know how many years now, and you know, you kind of understand how it goes together, the process. But I had to put complete trust in the folks up here, and that's hard, you know. But realize what they do well. You know, look at yourself. What do you do well? What don't you do well? Just being able to accept, acknowledge that, to bring on somebody and say, I need you, this is you, I'm not gonna tell you how to do it, I'll help guide you. So I don't know if I'm really answering how you trust them, but it's absolutely imperative in a building like this.
You know, it's important because trust and vulnerability are kind of in the same hand, right? It's talk about recognizing that you don't know something, and for and obviously when you're getting a project, when you're pulling it in, of course we can do it, and then like you talked about, when you get in, now you got to actually deliver a product and figure out how to kind of reverse it and put it into place. And so this team talked about the early collaboration being a huge success for that group and how we kind of engage. So are there any other questions out there for this team that's done a great job of putting a really cool space for some of the musicians out here? We have no questions. We've answered them all. All right, team, I'm gonna kind of finish you all off with one kind of final thought. So, biggest challenge that you personally kind of experienced on this piece, for you individuals, or each individual, give me your biggest challenge and your biggest win, right? So the biggest hurdle you had to deal with, and then what was the biggest or the most kind of the proudest moment that you have in this piece?
From my standpoint, I would say assembling the right team. That's not only these folks up here, but internally. We have a team of, I believe, 11 folks out there. That's a massive team for a design builder, a general contractor. So many ins and outs, so many different tenants, different contracts on this project. So without that, we would not have been a, say, smooth flowing operation, which I'm sure you all have seen it before. If it doesn't start there, then it doesn't translate down, and Will scrambling because he can't get in to assemble the right team internally and externally was the biggest challenge for myself.
It's really two things. It was this is the first time I've done anything like this for the towers. Okay, so that was a big just, you have to know what you don't know, and since we hadn't done this, it was a bit of a leap to move forward with it. But it's, for the engineers in the room, right? It's engineering mechanics. You figure it out, you check all the boxes, and if you go, yeah, this is good, then it's good. The other big one was, we're a very small firm, and you know, the Maris team, one of their divisions is they have in-house architecture, and when we were discussing doing this project, the question was, how deep is your bench? And I said, deep enough. So this was a very big project. 3 buildings, a large mezzanine. We didn't get into anything with the other buildings, but kind of some interesting geometry and lateral concerns in some other areas. And we, at times we had basically the entire office working on this job. We typically do more, I'd say vanilla industrial projects, right? Big boxes. Maybe they have a little bit of a design element to them that you have to figure out, but a lot of it is rinse repeat. That's just kind of the market that we're in. So to be able to pull this off and be associated with this will be the project probably that defines my career. That's not lost on me, and I'm very proud of it. So
I think one of the biggest challenges that I face is that when we were recommending product, we were recommending product that wasn't in stock, and there was really no way around it. And some of it was more precast related as well, so we were adapting it into a tilt-up scenario and relying on a lot of late evening phone calls and early morning phone calls for weeks, to the point where we were coming down to, we had days to get certain things off of airplanes and onto a job site. With all the planning that went into it, that was another trust factor that really came into play with the people that then once we were brought on board, that we also brought on board on the manufacturing side. So it was we were cutting it really close on a few items, but I never lost faith.
Same thing these guys were saying. I mean, there was only so much planning and drawings and connections, and is this going to work? Is this not going to work? It came down to the field. It came down to the guys in the field, the guys that are doing it every day, the quality control. We had 1,070 something embedded connections. We had 3 of them off. We knew about 2 of them before we started erecting. So it just came down to the field and the experience those guys have, the suppliers and the craft guys. So.
Well, all right, folks. So let's give this team a hand here. So great presentation they put together.